Today we will continue looking at solving single variable equations using addition or subtraction. So let's get started. So here we have a single variable equation. It's called single variable because it only has one variable. We will look at two variable and multivariable equations later. Our goal in solving equations is to get this variable all by itself. So the variable x will be on one side of the equal sign, and everything else will be on the other side. And it will give us the value of x that when we plug it back into the original equation will give us a true statement. In the previous lesson, we focused on solving equations like this using a few properties of addition. One property is the identity property of addition. And we call 0 the additive identity because when we add 0 to any number, that number is returned. So our goal is, instead of having x plus 5, we would have x plus 0, and that is x. Well, how do we turn 5 into 0? We do that with the additive inverse. So the additive inverse of a number a, and we write that as negative a, or the opposite of a, is the number that when added to a, we get 0. So a plus the additive inverse of a is 0. So if we have x plus 5, the additive inverse of 5 is negative 5. So we're going to go plus a negative 5. But we have to keep the equation balanced, so whatever we do to one side, we have to do to the other. So we're going to go 11 plus negative 5. So a number plus its additive inverse, that's 0. So we have x plus 0. And then this is 11 plus negative 5. Well, that's 6. And then x plus 0 is x, and we have x equal to 6. We can do a quick check of our answer. So what we're going to do is wherever there is an x, we're going to put a 6. So we have 6 plus 5 equal to 11. And then we're going to simplify down this left side. 6 plus 5 is 11. We have 11 equal to 11. Well, that's a true statement. 11 is equal to 11. So x equal to 6 is the solution to this equation. Now we can also use inverse operations to solve equations. So addition is the inverse of subtraction, and subtraction is the inverse of addition. So to solve these using inverse operations, we're going to start with x, and we've added 6 to it. So we have x plus 6. So the inverse operation of addition is subtraction, so we're going to subtract 6. And once again, what we do to one side, we do to the other. So if we subtracted 6 from the left, we're going to subtract 6 from the right. 6 minus 6 is 0, so now we have x equal to 11. Checking our answer, we'd have 11 plus 6 equal to 17. 11 plus 6 is 17, so we have 17 equal to 17. With the second problem, we have x minus 6. So we're starting with x, and we're subtracting 6 from it. The inverse operation of subtraction is addition, so now we're going to add 6. And what we do to one side, we do to the other. So now we have plus 6 on the right side. Negative 6 plus 6 is 0. So we have x on the left side. 17 plus 6 is 23. Checking our answer, we have 23 minus 6, and that's equal to 17. And then when we actually do this math, 23 minus 6, we have 17 equal to 17. And that's a true statement. Let's solve this equation using both methods. We'll first solve it using the properties of addition, and then we'll solve it using inverse operations. So we have x plus 12, and the additive inverse of 12 is negative 12. And then what we do to one side, we do to the other. So this is 27 plus a negative 12. 12 plus negative 12, that's going to give us 0. So we have x plus 0 is equal to, and then now we have 27. This is plus a negative. That's the same as subtraction. So we have 27 minus 12. And this gives us x equal to 15. This is how we would solve this using the properties of addition. Now let's solve this using inverse operations. So we started with x, and then we added 12 to it. So we have x plus 12. This is addition. The inverse operation of addition is subtraction. So we're going to subtract 12. And then what we do to one side, we have to do to the other. We have to keep the equation balanced. So we're going to have 27 minus 12. 12 minus 12 is 0. So now we have x equal to 15. Now I intentionally left this gap here. When we added this additive inverse, we have plus a negative. We can convert this into subtraction, and that would give us x plus 12 minus 12 equal to 27 minus 12. So I've converted all those additions of the additive inverse into subtraction. This is the same equation. So whether you use the properties of addition or inverse operations to solve these equations, you'll end up with the same basic equation to solve these. We'll quickly check our answer. So we have 15 plus 12 equal to 27. 15 plus 12 is 27, so we have 27 equal to 27. Now when I solve equations, I will typically view it through the lens of inverse operations, as opposed to the properties of addition. But either view is correct. So here we have x minus 21. So we're subtracting 21, so therefore I need to add 21. So we have x minus 21 plus 21. And again, what we do to one side, we have to do to the other. So we have 44 plus 21. Minus 21 plus 21, that's 0. So we have x equal to negative 23. Checking our answer, we have negative 23 minus 21 equal to negative 44. Negative 23 plus a negative 21, we're going to add those and then keep the signs. So that's going to give us negative 44. And negative 44 is equal to negative 44. That's a true statement. In this problem, we have y plus 11. So we're going to subtract 11 from both sides. We can also do this by just writing the subtraction underneath. I believe I was doing it like this in the last lesson. Just another way of kind of keeping track of what you're doing. So we're subtracting 11 from both sides. So y plus 11 minus 11 is y. And then 26 minus 11 is 15. So checking our answer, we get 15 plus 11 equal to 26. Again, I just plugged in a 15 wherever there's a y. Now we're going to simplify this side down. 15 plus 11 is 26, equal to 26, and that is a true statement. Now let's pretend that as we did this arithmetic, 26 minus 11, that we got y equal to 14. So we subtracted wrong. We made an error when we did our math. When we check our answer and we plug that back into the original equation, so where there's a y, we're going to put a 14. So we have 14 plus 11. That's equal to 26. We do this math step, 14 plus 11. Well, that's 25. 25 equal to 26. Well, that's not true. That's a false statement. Somewhere things are not matching up. And in this case, it is because y equal to 14 is not the correct solution. So the process is going to be the same whether you're using integers or fractions and decimals. So here we have x plus 3/4 equal to 2/3. We have 3/4 added to x. So we have x plus 3/4. So we're adding a 3/4, so therefore we're going to subtract 3/4. And then what we do to one side, we have to do to the other to keep the equation balanced, to make sure that the right side and the left side stay equal to each other. 3/4 minus 3/4, that's 0. So we have x equal to, and now we're subtracting fractions. So when we add and subtract fractions, we need a common denominator. A common denominator here is 12. So that's 8/12 minus 9/12. We now have a common denominator. 8 minus 9 is -1. So we have x equal to -1/12. Doing a quick check, we have -1/12 plus, I'm going to go ahead and convert this to a common denominator right away. That's going to be 9/12. And that's equal to 2/3. -1 plus 9, that's 8/12, is equal to 2/3. And then simplifying that down, this is 2/3 equal to 2/3. And that's a true statement. And finally, y minus 1.7 is equal to 4.65. So we're subtracting a 1.7, so we're going to add 1.7 to both sides. Plus 1.7. This is going to give us y equal to, and then just do a quick review of adding decimals. So we have 4.65, and then when we add and subtract decimals, we need to line up those decimal points. So 5 plus 0 is 5. 6 plus 7 is 13. We're going to carry the 1. Then we'll bring down that decimal place as well. And this is 6. So y is equal to 6.35. Checking our answer, we have 6.35 minus 1.7 is equal to 4.65. Again, we'll do our subtraction. We have 6.35 minus 1.7. Lining up those decimal points. 5 minus 0 is 5. 3 minus 7 we can't do, so we're going to borrow from here. Now we have 13 minus 7 is 6. Bring down the decimal place. 5 minus 1 is 4. So this gives us 4.65 equal to 4.65. And that's a true statement. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 4 problems. So for the first one, we subtract 17 from both sides. That gives us x equal to -48. On the second problem, we're going to subtract 1/7 from each side. Again, when we do fractions, we do make sure you have the common denominator. In this case, it will be 14, leaving us with y equal to 5/14. For the third problem, we're going to add 2/5 to both sides. I also went ahead and converted this, so 1 1/3 is the same thing as 4/3. From here, we need a common denominator, 15, and then we add the numerator, and you can leave it either as 26/15, or you can convert it to a mixed number. And once again, when you're adding and subtracting with decimals, Make sure those decimal points line up. Continue practicing solving equations, and I'll see you in the next video.